Okay, we are continuing our discussion of integration. And what we're going to do here is we're going to notice, well, there's no real way to get around this one. U substitution doesn't work. I mean, you could try different methods, but what we have to do here is a partial fraction decomposition. So what I'm going to do is I'm going to put the integral on pause. I'm going to look at my, algebra here, 6x minus 16. And I'm going to set it up so that I can factor this. And the factors here, you should be really good right by now on factoring x plus 4 times x minus 6. So that's the trick to solving this one. You have to be able to factor. All right. So then we set up two fractions, a over x plus 4 plus b over x minus 6. And we're going to multiply all of this by that x plus 4 and x minus 6 business and distribute it all the way across so we can see what we can eliminate here. So I notice in the first fraction there, I eliminate the denominator completely. I end up with 6x minus 16 equals, and I'm left with an a times, and in this case the x plus 4 eliminates, so x minus 6 plus b times, let's see, the x minus 6 eliminates, so x plus 4. All right. Now, this one, you can go about it a couple of different ways. In this first example, I'm going to go about it the systems approach. And then in the second example, I'm going to use an alternate method that you might actually like a little bit better. So let's go ahead and take a look and see what that looks like. So this is the systems method first. This requires me to distribute, and then we're going to kind of move some terms around. So I'm going to say 6x minus 16 equals ax minus 6a plus bx plus 4b. Okay, so I've got that right there. All right, so this is, again, my systems approach. All right, now what I'm going to do here is I'm going to regroup everything, and I'm going to say, well, let's group the x terms together and the constant terms together, okay, because this is going to serve a purpose. We're going to match things up here. First thing I'm going to do is I'm going to factor out the greatest common factor for the first two, which is x. Now the rest I'm going to group together just like this, and I'm going to equate the terms here. So I'm going to say, well, 6x corresponds to this a plus bx, and then the negative 16 corresponds to this negative 6a plus 4b part. So this is where I'm saying I'm going to get my system. The first thing I'm going to say here is a plus b equals 6. Okay, we don't need to worry about the x. And then the negative 6a plus the 4b equals a negative 16. And this is my system that I've set up. So what I'm going to go ahead and do is I'm going to take this first row and I'm going to multiply it by 6, because if I multiply it by 6, I can eliminate the 6a. So let's see what that looks like. I have 6a plus 6b equals 36. And then over here, this carries straight over. Negative 6a plus 4b equals negative 16. What do I get? Well, I eliminate my a terms, which is what I wanted to do. I get 10b equals a positive 20. So divide both sides by 10, and I get b equals 2. So that's the first part of what I wanted to find. Now I need to find a. Well, a is very easy. I'm going to back substitute my b right here. And so I can say then a plus 2 equals 6. So this is a no-brainer. A equals 4. All right, so a equals 4. All right, now notice these are not our answers. We just simplified the process now of integration. So let's go ahead and take a look at our original fractions, because that's what we're going to integrate. So let's take a look. Let's see here. I have the integral then of a over x plus 4, which is 4 over x plus 4. And I'm going to say dx plus the integral of 2 over x minus 6 dx. Now look at this. This is a lot less complicated than the original integral if you look at it. All right. This is not terribly difficult. Okay, this right here is natural log stuff. Okay, because if you know anything about the integral of 1 over u du, is that it is the natural log of the absolute value of u plus c. Okay, so in this case, our u can be x plus 4, but du is just 1 dx, so we don't need to worry about it. And the same thing goes for the second integral there. So very simply put, the 4 in the first is our coefficient, the 2 in the second is our coefficient for our natural log functions. And we're basically done. So 4 times the natural log of the absolute value of x plus 4 plus 2 times the natural log of the absolute value of x minus 6, and then we add c. All right, so we get that right there, and we have our answer. Okay, nothing to it. So let's go ahead and take a look at one more integral in this video. And again, the same kind of deal, partial fraction decomposition. This one slightly more complicated. Slightly more complicated because it's going to break up a different way. So this is what this integral looks like. It's 3x squared minus 29x plus 10 over x cubed minus 6x squared plus 5x dx. Well, what we're going to do is we are going to break up this monster, all right? And really we're focusing on the denominator here. The denominator here is an x times, because I'm factoring out the greatest common factor, x squared minus 6x plus 5, okay? And then I can continue to factor it a little bit more because the x squared minus 6x plus 5 factors into x minus 1 and x minus 5. Again, if you're struggling with the factoring, go back and view some videos on factoring, okay? Well, now that we've got that in place, I have 3x squared minus 29x plus 10 over x times x minus 1 times x minus 5, and I have now 3 partial fraction decompositions that I'm going to set this equal to. That's first is a over x plus b over x minus 1 plus c over x minus 5. So at the end of the day, I'm going to have probably 3 integrals that I'm going to have to look at. All right. And I'm looking at it now, and I'm thinking that it's probably going to be natural log stuff again. All right. Probably going to be natural log stuff again, but let's figure that one out. First thing we do, of course, is eliminate the denominator. So I'm going to multiply everything by this x times x minus 1 times x minus 5. And I distribute across the board here. All right. So that's what we do first. All right. This is going to give us 3x squared minus 29x plus 10 equal to, now in the first case, the x term eliminates. So I'm going to be left with a times x minus 1 times x minus 5 plus, and in the next case, the x minus 1 factor eliminates. So we're left with multiplied by x and x minus 5. All right, and in the last case for c, okay, we're going to eliminate the x minus 5, but we are still left with x and x minus 1 that we multiply by. Okay, so really not much to it, but we're not going to do the monster that we did in the last one, which creating a system. I think it'd be too complicated. So what we're going to do is we're going to pick wise choices for x. All right, so the first thing I'm going to do is take a look. Well, what would make some of this stuff 0? Well, here, x equals 1 would make that 0. Here, x equals 5 would make that 0. And here, x equals 0 would make that 0. So those will all come into play. All right, I'm going to start off with, let's say, x equals 5, and then I'm going to work my way down. All right, so let's assume x equals 5. Okay, so this isn't too bad. I'm going to plug in 3 times 5 squared minus 29 times 5 plus 10, and I'm going to set that equal to, let's see what happens here. That's going to eliminate this right here and this right here. So in that case, I'm just going to be left with c times 5 minus 1. Okay, So just think about that for a second and why I didn't write all of that stuff out. All right, so you probably have a calculator handy or something. 5 squared is 25 times 3, 75 minus 29 times 5. So let me just write this out for you. I'm doing mental math. 75 minus 45 plus 10. You do that math, and over here you have 5, and this is 4. 5 times 4 is 20, so 20c. 75 minus 45, negative 70 plus 10, negative 60 equals 20c. So you divide both sides by 20. So what does c equal? In this first case, negative 3. So we're going to need that, all right? And actually, let me just highlight it. I think that'll be helpful. If c equals negative 3. All right, so we know c now, all right? We know c now, but let's go ahead and continue. Let's say x equals 1. All right, so we again plug in the 1 now. The same process, okay? Let's see what that yields. All right, if we plug in 1, that's going to eliminate this here and this here. So we're just left with the b. All right, so we're going to say b times 1 minus 5. All right, we have here 3 minus 29 plus 10 equals 1 times 1 minus 5, negative 4b. Negative 4b. All right. 3 minus 29, negative 26 plus 10, negative 16 equal negative 4b. So we divide both sides by negative 4, and we say that b equals a positive 4. Very good. We're almost done, all right? Well, we're almost ready to integrate, I should say. But the integral is probably the easiest part. X equals 0. 3 times 0 square minus 29 times 0. I love 0. It makes things so much easier. All right. Now let's take a look. What are we eliminating here that we don't need? Well, we're not going to need the b, and we're not going to need the c. We're just going to leave this a part. Okay, so that's all we're worried about here. All right, is the a. All right, so we're going to have a times, we're going to set that equal to anyways, a times 0 minus 1 times 0 minus 5, which is eliminates this and this. All right, we have a 10 equals a times negative 1 times negative 5. So 10 equals 5a, in other words, so we divide both sides by 5. We say then a equals 2. All right, a equals 2. There we go. We now have everything we need for our partial fraction decomposition. We're going to take it back here a ways. Let's see if I can zoom out a little bit more to get my partial fractions there. All right, a in this case was 2. So we have 2 over x, and I'm just going to write it all as one big integral. Okay, 2 over x plus 4 over x minus 1 plus negative 3 over x minus 5, and then dx. And we know all of these are just going to be natural logs, so we don't really need to worry about them when we integrate. The first one is going to be 2 times the natural log of the absolute value of x plus 4 times the natural log of the absolute value of x minus 1 plus, and I guess you could say minus, but plus a negative 3 times the natural log of x minus 5. Let's see here. Let me erase that just a bit. X minus 5. And then, of course, we cannot forget our constant of integration, c. So there you have it. Our partial fraction decomposition integration. So, as always, I hope this video was helpful. And remember, like and subscribe.